Alright, hi girls. So I'm just going to finish off yesterday's lesson really quickly because there's not a lot left. If you weren't here for that, feel free. I'm going to send the link for this note to you. So I think that was just Emily, Evelyn, and Helena. Okay, so watch out for that in your emails. Make sure you also look at the other worksheet that I sent you yesterday. It's the formal way to show continuity. Okay, so make sure you do that in an exam situation. All right, so we're going to look at the gradient of a chord or a secant with function notation. So we looked at this one, okay? If you don't really understand it, feel free to ask me. So let's look at the second one. This is the one that we're predominantly going to look at. And this is the difference quotient to find the gradient. Now remember, the gradient is also the average rate of change, okay? So let's say I have an arbitrary graph, right? So this is my graph, okay? And let's say it's a parabola, and I want to find the gradient of a chord that lies on this graph, right? So let's say this is just some arbitrary function, right? The corresponding y value would be when I sub it in. Okay, and let's say this value here is just x plus h, which is just the difference between the two x values, which means this is f of x plus h. Okay, and then to find the gradient of said chord, or the average rate of change, okay, would be rise over run. So m would equal, well, the rise would be f of x plus h minus f of x, and the run would be x plus h minus x, which is just h. That's how we end up with that formula. Okay, so the chord, or the gradient of a chord or a secant, can be found with that formula, or it can be found with this one, where we use x and c. But this one's the one that we use most often, okay, where h is just some x or some coordinate a bit further away from x. If we look at this, what does h have to approach, or so this length of h have to approach to find the exact gradient at x? Well, h would have to approach 0. And that's what we're going to have a look at next lesson to find the exact gradient, which is why we actually had to learn limits. So as the limit, as x approaches 0, that will tell us the gradient at a specific point. But we'll look at that more next lesson. And for this one, x would have to approach c to find the exact gradient. Okay, to close that gap as another point, as we keep getting closer and closer to the x. So if I kept getting closer and closer, okay, x would, or h would become even tinier, right? So as h approaches 0, we'll find the exact gradient. However, we are going to use just the difference quotient, or the first one, to find the gradient of a secant, of cot. Now, this is a mesh between trig and calculus. Okay, cot looks like this, where this is 90. Okay, and that point on the x-axis is 90, so not pi over 2. Pi over 4 is here, and pi over 3 is 60, so it would be somewhere here. So we're actually finding the gradient of the secant that goes through those 2 points that lie on cot. Okay, and to do that, we need the corresponding y values here. So we're just going to sub it into cot. So f of x equals cot x, which equals 1 over tan x. Okay, and then to find the corresponding values, or the y value, that would be f of pi on 4, which is 45, 1 over tan 45. Tan 45 is 1, so the corresponding y value is 1. The corresponding y value, where x equals pi on 3, which is 60 degrees, okay, tan 60 is actually root 3. And so that value here is 1 over root 3. So this is just a y2 over y1 situation. So y2, so here it's pi over 4 comma 1. Sorry, this is 1, the other way around. Sorry, this is 1 and this is 1 over root 3. So this is pi on 4, 1, and this is pi on 3, 1 over root 3, which we should technically rationalize. So it becomes root 3 on 3. So m equals y2 over y1, so root 3 on 3 minus 1 over x2 minus x1, so pi on 3 minus pi on 4. Okay, and then when I do the denominator and numerator separately, I end up getting root 3 on 3 minus 3 on 3 to make it the same denominator at the top. And then I do 4 pi on 12 minus 3 pi on 12 at the bottom to make the denominators of the bottom the same. And so I get root 3 minus 3 on 3, and I get pi on 12 at the bottom, which is the same as doing root 3 on 3 over 3, root 3 minus 3 on 3, divide by pi on 12, which is the same as doing times 12 on pi, because you take the reciprocal and multiply it. But this you can cancel out already, that becomes 4. Okay, and then what they do is expand it out, so 4 root 3 minus 12 on pi is your gradient, which we have found. Okay? So that's all you have to do. To find the corresponding y value, use the gradient formula to do it. Now take note that the gradient on a distance time graph shows speed, and the gradient on a velocity time graph shows acceleration. We will explore this more later. Thank you, girls. See you later.